everyone, welcome back to my channel. I am Prachi Arora, an engineering student doing my community service by teaching Python on YouTube. Okay, so this is the 18th lecture and maybe it's the last lecture of our Python bootcamp. And today we will be covering the topics of OOP, that is object oriented programming. First of all, let's revise the last topic, that was scope. So, what is a scope? Scope defines the specific region of a program where a variable is accessible. I already told you it dictates the lifetime of the variables. And there are two primary scopes, that is local scope and global scope. And local variables that have local scope, they are defined inside a function and only exist during the execution of that function. Okay? So we can say that the lifetime of a local variable is a single function. As for the global variables are declared outside of the functions and can be accessed anywhere in the program. Okay, and the lifetime of global variables is the whole program. This is the global scope and this is the local scope. Okay, then we did two types of arguments, that were args and quarks. So what were args? Args were the arguments that can contain multiple arguments. They mostly receive a tuple of arguments. Okay, as for quarks, and it is represented by single asterisk sign and args. As for quarks, it is represented by two asterisk signs and quarks. It is also called keyword arguments, and args are called attribute arguments. So quarks arguments, the function receives a dictionary of arguments. Just like we give a tuple of arguments in arbitrary arguments, in keyword arguments we give a dictionary of arguments. Then we had a lambda function, that is a small anonymous function. That is, they don't have a defined name. Like this, you can say they don't use any particular keyword except lambda. For example, this we take a list A, and then we take a name and lambda x into 2 A. So it will iterate over the numbers of the list and give the output in the new list. This map is to make it iterate through the list, and here list to convert that iterated sequence into a list. Okay, so this was all about scopes, args, quarks, and lambda function. Okay, so for today's lecture, we go for lecture 18.py. Yeah, so what's the objective of today's lecture? That is OOP. And what is OOP? Object oriented programming. Okay, so OOP stands for object oriented programming. Now, what is object oriented programming? It empowers developers to build modular, maintainable, and scalable applications. Okay, it OOP is a way of organizing code that uses objects and classes to represent real world entities and their behavior. What does it consist of? OOPs mainly consist of classes and objects. Okay, in OOPs, object attributes has attributes, things that has specific data and can perform certain actions using methods. Okay, I will show you some basic definitions also as we do it. First of all, let's start with classes and objects. Then I will side by side I will tell you all about the other definitions, that's encapsulation, abstraction, polymorphism and inheritance. All right. So let's start with class. What is a class? Classes are the class is the blueprint for creating objects. Okay? And what does it do? It defines what an object should be like. You know what is a blueprint? It's like a simple definition of the object. Like what, for example, you can say we have a car of like we have a BMW. So what is the main blueprint for it? A car, right? The basic definition is same, that it should have four wheels and it should have a steering wheel, a brake, an escalator, like that. So the blueprint for all the cars is same, and then we create different types of cars in that, and those different types of cars are the objects. But the blueprint that it should be a car with a body, a brake, a steering wheel, four wheels, and it should be able to move, that should be, that is a class. All right. So we can also say that a class defines a set of attributes and methods that the created objects can have. Okay. Also, how do we create the classes? Classes are created by keyword class only. Attributes are always public and can be accessed by using the dot operator. Okay, I will show you that later on. First of all, let's try creating a class. For example, I will create a class. Let's see, should we create a class car? If I create a class car, it goes like this. Class, this class is the keyword. Okay, and then we give class name, colon, and then enter. Here we can give anything. For now, let's give pass. So we have a car. So this car is a class now. Okay. And it will act as a blueprint for the car objects. Right. Just like that, we have, I will use the same example later to explain the objects. We have object. What is an object? Object is an instance of a class. You understand? It's an instance of a class. It represents a specific implementation of the class and holds its own data. It's created based on that class. Okay? And an object consists of a state that it is represented by the attributes and reflects the properties of an object, and behavior of the object, that is, it represented by the methods of an object and reflects the response of an object to other objects. Okay. And identity, that is, it gives a unique name to an object and enables one object to interact with the other objects. Now, how do we create an object? Yeah, like for example, in the car, under the car, we have objects like Volvo or Toyota. So I will go like, we will give object name Volvo equals to, and then car name, that is the class name, and the brackets, and hence our object Volvo is created. Okay, that's how Volvo object is created. How it's defined now? It is defined with class name this, like that. Okay, so now you know what are the classes and objects. For a single class, you can create multiple objects. Like here, I did Toyota equals to another object, and here Toyota and Volvo both are objects. Toyota is not equal to Volvo, but they both are objects of the same class. Hmm? Now that you know this, that we have to give a single class code, and it can create multiple objects. So, what do you think are the advantages of OOPS? The main advantage is that it provides a clear structure to the programs. Object oriented programming provides clear structure to programs. Also, it makes code easier to maintain, reuse, and debug because we have a single class that we can repeat whenever we need an object like that. So, we can say that it helps to keep our code dry. And what do you mean by dry? Don't repeat yourself. Okay? It means we don't need to repeat the same set of code again and again in our program, and it helps us to reduce the code. Also, it allows you to build reusable applications with less code. Okay, so now you know what are objects and classes, and we have created a simple class and object. I will show you now. If I take inside the car class, if I take x equals to 10, and here I take print, print Volvo dot x. This x equals to 10 here is the attribute, one of the attributes in the class car. And by doing this object name dot attribute, we are accessing that attribute. So it should print here 10. Let's run and see. Wait a minute. Let's run this. Here you can see we are having 10 as the output. Okay, that's how you access that. Now I am only using the Volvo, so I want to delete the Toyota. So how do you delete an object here? I delete using del operator. Del Toyota, and it will be deleted. See, okay. So I already told you we can have multiple objects. So if we don't delete, we can also access the same attribute using Toyota dot x, and it will also print 10. See, like this. Okay. Each object is independent and has its own copy of the class properties. Okay. Later on, give when we give the attributes that need to be taken from the user, every object can take its own different attribute, right? Okay. So for next one, I will tell you what is init method. Which method? Init method. This one. We have to take double underscore, then in it, double underscore and round braces. And inside it we have a thing called self. Okay. What is this method now? This is a built-in method okay, which is always executed when the class is being initiated. Okay, you can do it like this. So init method is a built-in method which is always executed when the class is being initiated. And this method is used to assign values to object properties or to perform operations that are necessary when object is being created. Okay, so you can say that this method is used to assign values to object properties or to perform operations that are necessary when object is being created. Other attributes only work when you call them. Other attributes or methods only work when you call them. But this init method will always work no matter what. Okay. As long as you make an object, it will always work. So let's see an example for it, right? Example, let's take a common class. So common example, class person colon enter. And how do we do it? We make it same as we create any function. A method is a function inside a class. Okay, so we go for def keyword and then double underscore in it, double underscore and self. I will tell you what self is. Okay, for now only see this, that self is necessary to give. You can give any keyword. Self is not a keyword. You can give any word instead of self, but most of the programmers use this one only. Okay, so we give, let's give this person a name and age, and here we give a colon, and then we give self dot name equals to name, and self dot age equals to age, right? So this is our class. Now we take a person. Let's take P1 equals to person. Now when I give the round brackets, we have here attributes. These. So we have to pass these attributes also, right? So here I give the name Joe and let's give age 23. Okay. So how do we access this? Now this name and age are the attributes of person class. So how do we access the attributes? By using dot operator. So we go for print object name dot attribute name, that is name, and print object name dot attribute name, like that, and we run it. You can see Joe and 23 is being printed. Now if I give another object as P2 and person, here I give the name Lila and age as, let's give age 35, and we print first of all empty, and then we print p2 dot name and print p2 dot age. So it will give us Joe 23 and Lila 35. See, like this. Like this we can have multiple objects. You can also give default values in the this method. Like if I give here age equals to, like all of them are of age 20, and then I remove the age from Joe, but I give the age of Lila, okay? So for Joe it will give me age 20 and for Lila it will give me age 35. Let's try. See, for Joe age is same as the default age 20 and Lila has 35, right? Like this we can give multiple parameters here, like we have given age, we can give country, email, phone number, city, whatever you want to give. But you have to give it like this in this format. self dot country equals to country. Next. Okay. This was init method. So what does self mean here? Right? We are using self and we haven't give the any value to self. So what is self? Self parameter is a reference to the current instance of the class. Okay. What is a self parameter? It is the reference to the current instance of the class, and it is used to access properties and methods that belong to the class. Okay, that's what self parameter is. The self parameter must be the first parameter of any method in the class. Like here, even in init method, it is the first parameter. Let's create another method here. Like I will create a method called greet, and it will also have self, right? And here let's give print hello, I am, and then we give self dot name. Okay, here we are using self again. And now if I give here print p1 dot greet, like this. So what should be the output? It should be hello, I am Joe. Let's run it. Okay, okay. We are having argument here also because it's not default, so we have to give that. And we run it. Here it's showing us hello, I am Joe, right? So the thing we are doing wrong here is giving print again. It's already in print, so we just need to give p1 dot greet, and here it will give us the perfect output, that is hello, I am Joe. See, like this. This is the output. The self parameter must be the first parameter. Okay. Then why should we use self? Because without self, Python would not know which object properties you want to access. The self parameter links the method to the specific object. Okay. Self, and as I told you, self is not a keyword. So any word can be used instead of self. Like here, if I use obj instead of self, and I will change it everywhere, obj, like this, and Here too, obj, here also. It will work the same. Let's run it and see. See, it's running the same. So we can have anything, any word instead of self, but we should use self as it is the convention in Python and makes our code more readable to others. Okay, just like this we access the attributes or properties using the self operator, and we can even uh, access methods using this. Like if here I have another method, def message, and inside it we have self. Let's change all these again to self. Change all these. Okay, so here message, we have our message equals to self dot greet, right? And then again print, we will print message plus welcome. Okay, now here instead of print we will have to give return, right? And here also we will have a plus, and then here we will print our message. Here self is used to access another method that is greet into the message method. Okay, let's run it. You have to deselect it. Yes, and then run it. Here you can see we are having hello, I am Joe and welcome. The format is a little wrong, like this, and we run it again. Hello, I am Joe, welcome. Okay, this was the self parameter. Now, what do you mean by class properties? Class properties are the variables that belong to a class. Like this name and age, these are the properties. Okay, and you know how to access it and modify it now. And you also know how to delete it by using the del operator. We can also add the properties here. Here I can give p1 dot country equals to France. And if I print p1 dot country, it will return France, like this. You can see France. So like this we can add properties by using again the dot operator, right? Then you know about class methods and methods with parameters. Let's do an example for methods with parameters. Let's make a class called calculator like this. And we will not give init method. Instead, we will be taking the parameters or the properties inside the method. Okay, we go for def add, and here we will have self a b. Okay, and return a plus b. Then we have another method def. Let's take multiply same self a b and return a multiply by b. And then we take a object called cal and give the object a class name like this. Here I give sum equals to cal dot add, and I give the numbers as 3 and 4, and I take mul equals to cal dot multiply and numbers as 5 and 6, and I print sum is as sum and print product is as, yeah, so it should give us 7 and 30. Okay, let's try running it. It's giving sum is 7 and product is 30. That's how you create methods with their own properties. A and B here are the properties. So the next topic that we have after this is inheritance. Python inheritance. So what is inheritance? It allows you to define a class that inherits all the methods and properties from another class. Okay, what is Python inheritance? It allows you to define a class that inherits all the methods and properties from another class. And these classes can be defined into two parts: parent class, that is the class being inherited from, also called the base class. Okay, then we have the child class, that is the class that inherits, also called derived class. Okay, so if I take an example here, like take a class again, person, right? Def init, and inside it, let's go for here. First of all, here, let's go for name and age. Hmm? Name, age, and inside it, self dot name equals to name, and self dot age equals to age. All right, and I give another method, def print info, and inside it, self, name, and age. These arguments. Then we give print self dot name comma self dot age, like this. Okay, now if I give a person p equals to person, and I give the name Joe and age as 20, and give p1 dot print info, like this. Hmm? And then I print it, so it will give me Joe and 20. Okay. Here we don't give arguments. Yeah, like this, because arguments are already given their properties. So here we go, Joe 20, right? Now, if after this I create a child class called class student. Now, how to inherit the features of parent and person in this? By giving round braces and person. This creates a child class. Now I create a P2 as student, and inside it I give, for example, let's give Mike, and age is 21. Age 21. And I give P2 dot print info, this. So will it give us Mike and 21? Because student doesn't have its own method called print info. It's only containing pass, but in it inherits all the methods and properties from the parent class, that is the person class. So yes, it will give us the required output. See, like this. So this is how inheritance works. Also, there is a function called super function. Which function? Super. It automatically inherits parents' properties. Okay, I will show you an example. Here, if instead of pass I give its own init method, see, I just pressed enter and it is already giving super.init name and age. It's it means it is taking name and age from this init method. Okay, and here I will just take another thing called self dot graduating year equals to 2027. ठीक है, and I print this p2 dot, let's print p2 dot graduating year like this. It will give us 2027. But if I try to print it for p1, print p1 dot graduating year, it will not get printed. Why? Because p1 is the object of person, not student. The properties in the child class are not inherited by the parent class. Only the child class inherits the properties of parent class. So it will give us an error here. See, attribute error. Person object has no attribute graduating year. Okay. This is what inheritance is. Next up we have polymorphism. Let's remove all this. Next what we have, polymorphism. What is it? It refers to methods, functions, or operators with the same name that can be executed on many objects or classes. Okay, what does it mean? It means we can have multiple classes with same name. Okay, multiple classes with same name or same methods also, right? For example, if we take function polymorphism, then we have a function called len function, you must know, and it works on strings, lists, and tuples, dictionaries too. So that is what a function polymorphism is. A method name is same and it works same but on different things, right? Just like that, we have an example for class morphism. We will take a class as car, okay, and def init self, brand, and model. Inside it, self dot brand equals to brand, and self dot model equals to model, right? And another method, def move self, and here we will print drive. Just like that, we will create another class called bot, and inside it was a init function, and inside it we will have same at function properties, brand and model, and again self dot brand equals to brand. Self dot model equals to model. And again a same function or method move self, and inside it we will print sale. Okay, now I take a object as car and give the class here like this, and here I will take Ford Mustang, right? And I give car dot move, and here I take bot equals to bot, and here I give Ibiza Touring 20 brand and model number. Okay, and I will give bot dot move. Now here you can see move function is same. This method move method is same for car and boat. So will it be like boat will print it as drive or car will print it as sail? No. This is what polymorphism is. Car will only use the move method in the car class, and boat will only use it in the use the move function of the boat class. So it means, and it will not give us an error that we have given the same name, it will give us an error. No, it won't. See, it's giving us drive and sail. This is what polymorphism is, right? Then after it we have encapsulation. Only definitions are required for that. I will show you encapsulation. What is encapsulation? It means encapsulation means keeping data, that is properties and methods, together in a class while controlling while controlling how the data can be accessed from outside the class. This prevents accidental changes to your data and hides the internal details of how your class works. Okay? And how do we use it? For example, if I give here model and I give underscore, it will give the model as private property. This becomes private property. Okay? And if we try to access the model, like if here I try to access the model, print car dot model like this, it will give us an error. I will show you. See, it's giving an error. It's showing car object has no attribute model when it clearly has it, because it's private. You can't access it outside the We can't access it outside the class, like that. And why is encapsulation used? It is used for data protection, validation, flexibility, and control over the code or classes. Okay, just like that, we can have private methods. If I give this move like this, it becomes a private method. We can't access it. And when we give board.move, it will give us an error. I will show you. See, it's giving an error. These private methods can only be used by other methods inside the class. Okay, so remember, to do that we give double underscore in front of the given thing. We can also have nested classes. Okay, so that's it for the oops. Okay, I think we have covered all the topics. Abstraction, we have left with abstraction. I will show you. What is abstraction? Is it is focused on hiding internal implementation details and exposing only essential features. It acts as a blueprint or structural context, focusing entirely on what an object does rather than how it does it. We have abstract classes, and for that we use import abc from, like this. I will show you. Import abc, or wait a minute, from abc import capital ABC and abstract method. Okay, and how we define it? We give it by, like this here, at the rate, we give abstract method. This is how an abstract base class is defined. Okay, it hides the complexity of the function and only show the essential interface, and it's imported from ABC module and used by abstract method. Okay, if a class contains at least one abstract method, Python will throw a type error if you try to create an object directly from it. You can't create an object directly from that class. We will have to make another class, like we will take here boat, and inside it we will have to take car. We can't give here this. If we call car here, it will give us an error. I'll show you. Just giving drive. but you can't make an object of car directly, or this directly. Abstract, uh, if I take here car, capital ABC, it becomes abstract class. And now we can't access the car. So it's giving type error. Can't instantiate abstract class car without an implementation for abstract method move. Okay, just like that. It kind of is same as encapsulation, but still it's different because abstraction hides the complexity and encapsulation restricts the access to data. Okay, so that was it for the today's lecture. We have covered whole object oriented programming. I told you about what the classes and objects are, then init method, then we did the self parameter, Python inheritance in that parent class, child class, and super function. Then I told you about polymorphism and encapsulation, and also about the abstraction. Okay, so this was the last lecture of Python. By now, if you have practiced side by side, I'm sure you have. um I'm sure you all understood the basics of Python. This was all about the basics. If you want to do more advanced course, you should be able to understand all these. So keep coding, keep practicing. That's it for today. Thank you.